post today's video as well. All right, so we're going to talk about Chapter 9, which is Observational Studies versus Experiments. Okay. All right. So one of the things I don't think they include in here, but I want to include this in here because I think it's important, is a census. Okay. A census is where you attempt to collect info on the entire population. Okay. So sometimes this can be the best thing to do, but sometimes not. So let me ask you, for example, let's say I wanted to test every light bulb I owned before I sold it to see how long it would last. Would it be a good idea to do a census on that?
That would take a long time.
It would take a long time. What would be another problem?
They'd all be dead.
They'd all be dead, right? I couldn't sell any light bulbs if I did the census. Okay? So it would be kind of crazy. So sometimes you want to deal with samples rather than a census. So we have two types of studies: observational studies and experiments. Okay? So observational means you observe and measure, and you don't attempt to influence. Okay? An experiment is to deliberately impose a treatment in order to observe a response. Okay? So a lot of people prefer experiments over observational studies because they think you can better isolate possible causes. However, so let's say, for example, I wanted to find out if smoking caused cancer. Okay? Now, if I were going to do an experiment, what I would do, let's say this room is in half, but we're going to pretend this is the middle. Okay? All right, you guys, you have to smoke. You guys, you can't smoke. We'll come back in 30 years and find out who gets lung cancer. Who wants to sign up for that experiment? Would it be ethical for me to force half the room to smoke? Okay? It wouldn't be ethical for me to do that. And so the tobacco industry got away with that for a long time. They're like, well, it wasn't an experiment. You could, you know. So a lot of times, especially with smoking, we relied on observational studies in order to find out if it caused cancer. Okay? We've done enough of them now that we know that it does. Okay? So let's see. Oh, there was a study done in the 1970s that said that sugar caused heart disease. Have you ever heard that before? Who's ever heard that before? Okay, you've heard that before? There was another study that said that it didn't. And we know sugar causes tooth decay, but does it cause heart disease? You heard that?
I haven't heard one about tooth decay.
You haven't heard about the tooth decay?
No, there was like one about how addictive sugar is.
Oh, sugar is addictive. I'll say that. But so one of the problems was with the experiment was what we call confounding. Okay? Confounding means the effect of two or more variables is not separated. This is due to what we call lurking variables. And my favorite definition for a lurking variable is what you forgot to include in your study. Okay? So let's talk about that for just a minute. So the original study said sugar caused heart disease. Second study said sugar has nothing to do with heart disease. Okay, you've got confounding going on. Okay? A lot of times I think of confounding as conflicting results. Okay? So the first study did not include whether the person was a smoker. Okay? Why would that matter, right? Do smokers consume more sugar than non-smokers? Turns out they do, especially in the 60s, because in the 60s there was no Starbucks, right? You had to drink your coffee black. Okay? And smokers, it turns out, smoking kind of dulls your taste buds. And I don't know about you, but does anybody like black coffee? Why? Isn't that nasty?
I like all the sugar.
Huh?
I like all the sugar in the Starbucks coffee.
Wow. Okay. Some people don't like it. But anyway, most people that drink coffee would pour a lot of sugar in there. It was nasty, right? But it turns out that smokers, as they're smoking, they're drinking their coffee, and they put a lot of sugar in their coffee. So it's not that smokers ate more sugar, they drank more sugar. So this is one of those cases where, you know, who knew that smokers consume more sugar? Is that something that you would normally think of? Probably not. And so, so we had confounding going on. So the original study thought that it was sugar that was causing the heart disease, but it was really the smoking that was causing it. Okay? So confounding due to lurking variables. That can be a big problem with observational studies because you can't control. Now, experiments, on the other hand, they have their own set of problems. A lot of times with drug studies, one of the things they will do is they will try to find people with whom the drug will work best on. Okay? So they don't get normal people. They kind of gear their results so that it will work because they want to get this drug approved so then they can make a lot of money on it, right? And so another problem with experiments is the fact that, you know, if you're in the hospital, you've got the nurse coming every 4 hours to give you your pain pill or whatever it is. And so you're taking it really well. Whereas, so with the clinical trials, you know, they've got these really stringent requirements to make sure you take the pills as you're supposed to. And so it works really well. Now they release it to the public, people forget to take their pills, it doesn't work as well. And so both kinds of studies have their own problems. But as a general rule, people kind of prefer experiments because you can a lot of times control your environment a little bit better, okay? All right, so let's talk a little bit about subjects, factors, and treatments. Okay. You could, another name for subject is individuals or experimental units. I should have given myself more room. I think I will. So you can think of this as an object defined by the data. Okay? Now, an individual could be an individual. It could be a crab. It could be a tree. It could be a rock. It could be anything you want it to be. In one of my examples that I use in another class, let's say you're in charge of figuring out how much people recycle. Okay? So, you know, you've got those big blue recycling cans in front of people's house. Would it make sense for a family of 6 to figure out how much every member of the family recycles. Okay? You probably, in that case, the individual or the subject or the experimental unit might be a household. A household. Okay? So a group of individuals. So you could define an individual as a household in that case. And then you could say, well, they have a garbage can in front of their house. We'll weigh the garbage can. We'll see how much they recycle. Does that make sense? Okay? We've also got factors. Another term for factors is variables. Okay? And a treatment is a combination of factors or variables. Okay? All right, we'll also talk about a control group. A control group serves as a baseline to compare the treatment against. Okay. All right. We'll also talk about blinding. Blinding is non-disclosure of treatment. Okay? We've got 2 types of blinding. We have single blind. Okay? That means that the patient doesn't know if they are getting a treatment or the placebo. I guess I ought to define placebo here. A placebo is a dummy treatment. Okay? Usually a sugar pill. Now the problem is, sometimes experiments can be hard to do because placebos work really well if you're doing a drug. Here's a pill, you don't know what's in it, you can take it, and that's fine. But what if I were doing a diet? Okay? You know what you're eating, right? Unless you have a blindfold on. Okay? But even if you have a blindfold on, you can tell if you're eating meat versus you're eating vegetables versus you're eating a Kit Kat bar, right? It's kind of hard to do a placebo diet, right? Okay. So, so sometimes you're going to have to rely on observational studies instead of experiments. But we also have what's called a double-blind study, where both the doctor and the patient don't know if they're getting treatment. Okay? Why would it be important for both the doctor and the patient not to know?
Privacy.
What did you say, privacy?
Privacy.
Why privacy?
I assume it comes down to like what information is like especially with medical documents, certain clause that
Well, if
protect.
the doctor's treating the patient, shouldn't the doctor know what the patient's getting? That would be another argument.
That's true.
Why would it be a good idea for the doctor not to know about the treatment? Yes.
Maybe bias.
Bias? What do you mean?
Like the doctor, maybe they specialize in something or they have like a feeling towards this treatment, but they don't want bias.
Yeah, exactly right. So the doctor might be biased towards the treatment. So there was actually a study done by a doctor. It was a single blind study rather than a double blind study. And one of the things that he did was he wanted to determine if he was treating prostate cancer, and he wanted to determine, I need a water, if surgery was a better option than drugs. So one of the problems that happened in this study, he found out that it looked like surgery worked better. But one of the problems was, he would look at two men, he would look at you and he'd say, you know, you're an old man. I don't think you'll be able to handle surgery very well, so I'm going to give you drugs. And he would look at you and he'd say, you know, you're a young man, you could probably handle the surgery quite well. And so the problem was, all the old people got the drugs and all the young people got the surgery. And so he was, and I don't think he did this on purpose, but he was unintentionally biasing his results. And so there was a lurking variable, and that was age that he wasn't taking into account. And so that can be a reason why you would have to do blinding. Now the problem is the patient knows, and I'm getting the dryer, they're cutting me open, right? Would it be a good idea? Would it be ethical? In fact, that's another thing. How do you do placebo surgery? We're going to cut you up, and then we're going to just sew you right back up and not have done anything. Is that a good idea? Why not? What's that?
Surgery is dangerous.
It could be dangerous. You could introduce an infection that the person didn't have, right? Okay? And hospitals are breeding grounds for germs, right? So you could introduce a staph infection or something. Okay. So, all right. Here, I'm going to put this up, I guess. This is a little harder to see if I go over there. So we're going to talk about a completely randomized design. Okay? And basically what that means is you're going to randomize subjects to treatments. Okay? Now, one of the things that we can do is, number one, we have to identify, well, before we do that, I'm going to do something over here. Steps for a good experiment. Number one, we have to identify the problem. And we need to be explicit. Okay? Just turn, it doesn't turn. It's getting really hard to read that. I wish I could move that over. That's not too bad, I guess. Okay. Now, let me tell you about a situation that happened to me. I was working at the University of Utah. I had a professor, and she was concerned about skin cancer. And she wanted to know, so what she said to me, she wanted to do an experiment or study in which she wanted to determine if people had better habits with relating to skin cancer. That was what she told me her study was. Okay? And my response was, how do you measure that? Okay? So you're me, or I'm you, or whatever. So you're trying to do a skin cancer study. You want to know if people are improving with relation to skin cancer how would you design that study? How would you measure it? This is why we need to be explicit. What do you guys think? Bueller? Yes, go ahead.
Can you repeat the question?
Okay. So you're studying skin cancer, and you want to know if people improve their habits with relation to skin cancer. How do you measure that? Okay.
If you have like a better habit of putting sunscreen on.
If you what?
If you have a better habit of like putting sunscreen on.
Okay, so how would you know if people were putting sunscreen on? Ask them.
Yeah.
Well, I don't understand what habits she wants to know about, because there's a lot of habits.
There's a lot of habits, right?
Yes, that could be anything.
I know, that's what I said. And so this can be the biggest problem, is identifying the problem. How do you actually measure that? If you're not explicit, like, I don't know what you're gonna do. Okay? So my question was, how do you measure that? Well, here's what she came up with. Tell me if you think this is a good idea. So what she said was, okay, here's what I'm gonna do. I'm gonna create a pretest. I'm gonna pass it out to a class, have everybody take the pretest. And they'll answer however they answer. I'm gonna collect the papers, then I'm gonna teach a class on wearing a hat and putting sunscreen on and long sleeve shirts. And oh, by the way, I just recently heard, have I told you my favorite websites? Statistics podcasts, okay? There's one called 538, you actually spell it out. I'm gonna write this down. 530, it's kind of a weird name, 8.com. It's a really awesome website. They talk about statistics and politics all the time. There's another one called Freakonomics. Just do a search for Freakonomics. Those are awesome. The other one is called The Hidden Brain. Hidden Brain does a lot of social science research. Freakonomics does a lot of economics. 538 does sports and politics. Awesome statistics websites. In fact, Freakonomics has a good podcast on how to do bad experimenting and why drug companies do it wrong all the time. What was I going to say there? Anyway, so she said she was going to do a pre-test, she was going to teach a class, and then she was going to have the post-test, which had the exact same questions as the pre-test. And she would ask people, are you wearing a hat? Are you wearing a long sleeve shirt? Are you putting sunscreen on? Oh, I know what I was going to say. One of the things, I think it was on Freakonomics, I can't remember, but I think that's where it was. They said that people who wear sunscreen get more skin cancer than people who don't. Why would that be? Maybe the sunscreen doesn't work as well as they thought. Maybe you have a false sense of security, and so you're in the sun longer because you're not getting a red burn, but that stuff still penetrates your skin, right? Okay? So you can learn some really cool stuff like that. It's really cool. So, but anyway, so that was her thing. My question was, okay, so you ask people that just had a class, do their habits really change just because they had a class? Do you wear a seatbelt? You probably should. Do you wear one? You know you should, right? Some of you smoke. You probably know it's bad for you. You still smoke. Does the knowledge change your attitudes? Do you wear sunscreen? Do you wear long sleeves? Got a few hats on in here. Is that because of skin cancer, or you just like the hats? I am a big Red Sox fan, by the way. So I should warn everybody. I haven't given a fair warning. If you wear a Yankee hat or BYU stuff, I'm going to tease you. So just before work. But Red Sox, I'm cool with that. So. And Broncos, that's the other one. Denver Broncos, I hate the Broncos. Okay? just so you know. Anyway. All right, so identify the problem. 2 is identify variables that affect the response variable. Number 3, find your sample size. Okay. We'll do an example here in just a minute. Number 4, I have this here. Let me see here. Determine the level of each factor or variable. Do the same thing. And what you're going to do is you're going to control and randomize. And number 5, you will conduct the experiment in which you will randomize subjects to groups and collect and process data. And at number 6, you will test the claim. Okay? Now the 2 ways we will do that are through confidence intervals and hypothesis tests. Okay? All right. So let's go through that. I started mentioning the completely randomized design. Normally, if I wasn't recording, oh, that's kind of, sorry, I just realized that's not on video, but now it is. I'm going to come back over here just because if some of you want to watch this at home, again, you'll be able to see it. So normally I'd keep going, but my camera won't stretch that far. Okay, so all right, let's do a little experiment here. Okay, so we're going to follow so we're going to do a completely randomized design. And we're going to follow our steps to do an experiment. Number 1, we're going to identify the problem. Okay? And so here's the problem. The farmer wants to know if fertilizer helps his plants. Okay? All right. So we've identified the problem. Step 2 says identify variables. Okay, so we're going to identify some variables. So what are some things that help plants grow? Water would be a good thing. What else?
Sunlight.
Sunlight. Okay. What else?
The soil it's in.
The soil it's in. What else?
Where it's at, like the environment.
The environment. Okay. Well, that can be something that's a little harder to control, right? But maybe we could put it in a greenhouse so we could control that a little bit better, right? There's a big one you guys are missing. What's that? Weeds. Okay. What are we trying to test? We're trying to test fertilizer. It would be good to put that one in there. Okay. So that's a pretty good list. Okay. Kind of low here. All right, so pretty good list. Now, if we put it in a greenhouse, we can control the environment. We'll put them all in the same soil. We'll control the sunlight, we'll control the water. Hopefully we'll control the weeds. The only one that we have left here is fertilizer, right? Okay. Step 3 says, figure out our sample size. The farmer says he's going to have 60 plants. He has enough money or whatever, enough space, whatever. So we're going to use 60 plants. Okay? So, so the idea here is maybe the one thing that we can vary on here, we'll try to keep all of these relatively constant. And maybe we'll try fertilizer, we'll try no fertilizer, we'll try 2 teaspoons and 4 teaspoons of fertilizer. Does that make sense? Okay? So, so we've got that then. So we've determined our level of each factor here. So everything else is going to stay the same, and we're just going to vary the fertilizer. So that's step 4. Step 4 is basically right there. Everything else we're going to keep the same. Okay. Step 5 says conduct the experiment. Okay. Now, in the homework, you're going to be asked to draw a diagram. And so this is the diagram I want you guys to be concentrating on. So the first thing, and this is what people always forget, okay, is to randomize. Now, here's what I want to say. It's on video, okay? Don't forget this step. I'm going to put this on the test, and some of you are going to forget to randomize as your first step, okay? But you're going to put it in to say group A, B, and C, okay? So you're randomizing to all 3 groups, okay? In group A, you'll have 20 plants. Group B, you'll have 20 plants. Group C, you'll have 20 plants, okay? Now, the one thing that we're going to vary here is the amount of fertilizer. So group A is going to get none. Group B is going to get 2 teaspoons. Group C is going to get 4 teaspoons. Okay? So that's our treatment. And then at the end, we're going to compare results. Okay? So if I ask you to draw a diagram of a randomized, completely randomized design, okay, that's what I'm looking for. Does that make sense? Okay. Okay, I need to make sure I'm following this here. We're actually going pretty fast. I think I'm going to add a few more homework problems to your thing here. But I would also like to talk about another type of experimental design. And that, so we're done with completely randomized design, okay? We're also going to do what we call a matched pairs design, okay? And so some of those studies can be really fun. You've got twin studies, you've got husband and wife. You can match on anything. You could match on socioeconomic status, something like that. So the idea with a matched pairs design is what you're going to do is you're going to match based on something. based on marriage, based on twins, something like that. I had to bring water. I'm not used to talking for 3 hours straight. All right. So there's a famous study that was done in Somerville, Massachusetts. I think started in the 50s, I think. And there was a Catholic priest. In fact, this was on Freakonomics again. You can tell I love Freakonomics. And he wanted to prevent or to reduce juvenile delinquency. Sounds like a good idea, right? Okay. So one of the things that he would do is he said, okay, so we're going to take these juvenile delinquents. Here's how we're going to match them. We're going to match them based on age, and we're going to match them on income, parents' income. Okay, so we take 2 15-year-olds, let's say, juvenile delinquents, and what he would do is he would randomly assign to a treatment. Okay. Now remember, with the completely randomized design, you randomize right off the bat. In here, it's the second step. Okay, it's not the first step; it's the second step. So you're first going to match based on age and income, let's say, and then you're going to administer treatment. Okay. And in his case, when the treatment that he decided that he wanted to administer was for half of the boys, he would assign them a mentor, is what we call it. Okay? So this is, you can think of like big brother, big sister, somebody that they could look up to, that they could go to for help. And then he would compute the difference for each pair. Okay? Now this sounds like it was a really good experiment, right? So what he found after doing this for a decade or so was that the boys who had a counselor reoffended more often than the boys who did not have a counselor. Isn't that weird? Yeah. So that was what he said. I must be doing something wrong. So after a while, he had to say, no, the numbers are right. And so he actually stopped the program because it was worse than doing nothing. Isn't that kind of weird? So, but that's an example of a matched pairs design. Okay. And so, so that's the kind of diagram I would be looking for in that case. Another treatment type would be what we would call the randomized, and this one might not be in the book, but I'd like you to know it as well. Randomized block design. Okay? And so you first divide into groups and then randomize. And it's similar to the completely randomized design. Okay? So you would have a blocking variable such as age, gender, something like that, something else. Okay? Now, a common blocking variable might be, say, gender. Okay? Now, it is actually fairly well known that men and women react differently to medications. Okay? In fact, this was another Freakonomics episode, and there was a drug, I'm trying to remember, but they used it to treat morning sickness. I think it was a sleep aid at the time. I'm trying to remember what it was called. Thalidomide, I think it was called. And so as most people are well aware, women get morning sickness when they get pregnant. So a bunch of women were taking a drug. I think it was thalidomide. It could have been something else. But anyway, they were taking this drug for morning sickness. The problem was that it caused severe birth defects. Really bad. Okay? So, so a lot of drug makers, as a result of that, we were talking about experiments a little bit earlier, a lot of drug makers says, okay, we don't want any pregnant women in our study, we don't want to cause a birth defect, which, you know, is a reasonable, well, in a way, it's a reasonable thing to do. However, so if you just got a bunch of men in the study, you don't know if the drug is safe for pregnant women, right? And a pregnant woman, if she has a condition, she might appreciate that. Okay? And so one of the things you can do is what we call a randomized block design. Okay? And so you'll have a blocking variable such as gender. So let's say you break it up into the men and you break it up into women. Okay? Now clearly that's not randomization. But at this point, so you've got your blocking variable, which in this case is gender, and then you're going to randomize. So once again, randomization you can think of as step number 2. Okay? And so what you'll do, so it'll look a lot like this. You'll still have treatment A and treatment B and C or whatever other treatments you'll do. But you'll do that for the men and for the women. Okay? You'll run the experiment and then you will compare the results. Okay, you'll run the experiment and you'll compare. Sorry, I ran out of room there. Okay, so you can see that visually it looks a lot like the completely randomized design. However, you've got this blocking variable, in this case gender. It doesn't have to be gender, but that's just a common one. And the problem is you can compare the men versus the men, and you can compare the women versus the women, but it would be a mistake to compare the men versus the women, okay? Because you're not randomizing right off the bat, okay? So a lot of times this is the type of study they will do with drug studies, for example, okay? So, so that's your randomized block design. Let me see here. Is there anything else that I want to include in here? I thought this would do. You guys don't ask enough questions or something. I'm getting done early. Let me make sure. I think that's about it.
One thing I was a little confused on the homework by what, like, you had 10.1 and then things off to the side.
So last time we covered all of chapter 10.
Yeah.
I'm glad you mentioned homework because I posted that quiz kind of late. Normally I'm going to have the homework due right before class where you just tell me how much homework you completed, but it was all of chapter 10. The way this book has laid it out, they put some problems in section 10.1 and some in 10.2. For the most part, I think I'm going to plan on covering the whole chapter. So it's more of just to help you to know where to find it. Does that make sense? But yeah, so last homework was all of chapter 10. The homework that's going to be due on Tuesday is going to be all of chapter 9. I do think I'm going to add a few more problems than I've already assigned here.
And we just do the homework, like...
Yeah, you just do it on your own, and then it's just to prepare you for the quiz. Now, did you notice that any of those problems look similar to the homework?
Yeah.
Yeah. So you'll notice that some of your quiz questions will come off the homework. Some of them won't.
So we'll only be based on our homework.
Yeah.
Like, we won't know if we did it right or not, unless it's on the quiz.
Well, aren't the answers in the back?
I don't know, I don't have to look at it.
Oh, you don't have the book yet? Yeah. Yeah, I think the odds are in the back. Yeah, so you can check that. So not the evens, but the odds. But you're welcome. Notice today in class, I said, do you have any questions at the beginning of class? I'll do that every time, and then we'll take our quiz. So because I got that quiz up a little bit late, if you haven't filled it out, you have until midnight tonight to tell me how much homework you did. That'll be worth 5% of your grade. So that's going to be due every class. I'll just make another one that's going to be due on Tuesday at 10 o'clock. That's when it'll be due. So, and it'll just be an honor system thing. But one of the things that I've noticed, because I don't collect homework, I'm hoping that you will still do it, and that, and I'm just going to trust you. I don't know. You could lie and say you did it all and you didn't do anything, I guess. But it's an honor system thing. But I would like to know approximately how much you did. So on Tuesday, the quiz will be on Chapter 9, all of Chapter 9. I am going to modify the homework today. I'm going to add a few more problems because I covered a little bit more information. I thought I was going to run out of time, and I didn't. So I'm going to add a few more problems to that. Yes?
Where's the statistics lab again?
The statistics lab is in the Low C Center, 301. Supposedly they have about 15 computers. But if you have a laptop, I see everybody's got a Mac in here. We've got 3 Macs, I see. So you're welcome to bring that on Tuesday. Check the announcements. I am not 100% sure if we will meet here. I'm actually right now, I'm going to walk over to the library. They have a computer lab in the library, and I'm going to try to get one of those. And I'll just post an announcement. So check your announcements. I'll try to post it today so you know on Tuesday whether we're going to have it here or in the library. So my plan is in the library unless it's full, and then we're going to have to try to do it here. So yes.
Would you mind posting another PDF version of the book?
Oh, who doesn't have the book yet? Okay, I will post the homework. I don't know that I can post the whole book. I don't want to get in trouble, but I will post the homework in there that's due. And then, yeah, I'll do that again. But hopefully you guys can get that pretty soon. So I know they have an electronic version. Tell me your name. What is it? Mo has it, and you had it. So that might be the fastest way to get it.
I have it too, and the ones at the library, they don't have them anymore. I went and checked, they're all out.
They don't have this version in the library?
No, not
They don't have it online either.
But online you can find it. I found it on a place called Vital Source.
Vital Source?
And it's
VitalSource.com?
$64.
What?
$64.
$64 for the electronic version.
Yeah.
If you want to get that.
That's the cheapest side,
That was the
At
cheapest
the
you could
bookstore,
find?
it's $50 for the ebook.
but they're not there anymore.
It's not at the bookstore
I
anywhere?
bought mine just yesterday.
Oh, you bought yours yesterday?
I bought mine yesterday.
Well, I checked yesterday, like later on, at like 3. and
They were out of the ebooks?
they're out. So maybe they came in.
I would check again. I
Check
just did
again.
for a different class, but they.
But I would also mention this, go to the math department downstairs and tell them that they're out. Yeah, okay, I didn't know that, so. Okay, I will post the homework again for Chapter 9. And I will update that as well. So if you've already printed out the homework, I'm gonna add a few more problems to that. So. Okay. All right, anything else?
Yeah, can we take a picture of that?
Take a picture of this, it's gonna be on video.
Oh,
What's that? Yeah, I've got the video. So you can watch the video, I'm still recording, so. All right, well, we won't let you out of class every day early, but you got lucky the first week of class, okay? All right, see y'all on Tuesday.